Hello and welcome to today's video of how to get our math done. Sorry to everyone who came to the class chat. My internet wasn't working. So the first question of the lesson today, I don't really want to go over too much. You should all be able to have a handle on this pretty easily. 10 to the negative 3 is 1 over 10 to the power of 3. 10 times 10 times 10 is 1,000, 1 over 1,000. The word for that is millimeters, 1,000 millimeters in a meter. 10 to the negative 2 is 1 over 100 centimeters. 100th of a meter is a centimeter. 10 to the 3, 10 times 10 times 10 is 1,000. 6, 10 times 10 times 10 times 10 times 10, I think that was 6, whatever, 6 times. 6 zeros. 9, 9 zeros, 9 zeros. 10 to the 12, 12 zeros. The big important idea of this is 10 to a power is just a 1 with that many zeros after it. And if the number is negative, it is 1 over a 1 with that many zeros after it. For each number, think of something in the world described by that. I'll leave that up to you. This right here is the big important piece of today's lesson. These are all representative of number blocks, base 10 blocks. You might remember these from elementary school. 7th grade uses them a little bit, I think. A, over here we have 4 units and 2 100s. B, over here we have 2 100s and 4 10s. And C, over here we have 2 10s and 4 1s. Now we have to think about how we could represent these numbers right here. The big important piece of this is, like I said above, a 10 with a negative 1 is 1/10. That means we're dividing by 10. 10 to the negative 2 means 1 over 100, so we're dividing by 100. 2 tenths and 4 times 100ths is 0.24. Now, which one of these, A, B, or C, is best represented by 0.24? Well, that could actually be B or C. If you think about the number 0.24, that's the same as 240 or 24, but just with the decimal place moved over a few spots. A lot of what we're going to be seeing in these is decimal places moved around by a few spots. Now, the next one here, we have 2 to the negative 1, or 2 times 10 to the negative 1. That's 0.2. Now we have 4 times 10 to the negative 3. That is 0.004. Now, it looks like this video is going to end pretty soon, so I will stop it and continue in the next video. Okay, continuing on. Here we had 2 times 10 to the negative 1. Here we had 4 times 10 to the negative 3. Negative numbers mean we move the decimal point that many spots, but we do it in the direction that makes it smaller if they're negative. So 2, and we move the decimal point 1 spot. 4, and we move the decimal point 3 spots. Combine those together, and that's number 0.204. So if we scroll back up, which one of these could be the number 0.204? Well, that has to be A. A, 204, is the same as this with the decimal point moved around. Our next one here is 2 times 10 to the 3. So 10 to the 3, 10 times 10 times 10 is 1,000, a 1 with 3 zeros after it. 2 times 1,000, 4 times 10 to the power of 1, 10 to the power of 1 is just 10. 4 times 10 is 40. We're adding those together, 2,000 plus 40. Which number would that be? 2040? That could be B with the decimal point moved over 1 spot. Nope. Sorry about that. That's not B, that's A with the decimal point moved over 1 spot. 204, this is the one with the 204. Now D, 2 times 10 to the 3. So a 2 with 3 zeros after it. 4 times 10 to the 2, a 4 with 2 zeros after it. 402,000, we put them together. Which could that be? Well, that could be B or it could be C. B and C both work for that. 2,400, 24, we multiply that by 100, that gives us this. B, multiply it by 10, that gives us this. So now the next one, it says write an expression to describe the base 10 diagram if each small square represents 10 to the negative 4. 10 to the negative 4 means, think about 10, the decimal point would be here. Okay, for this we want each square to represent 10 to the negative 4, which means 1, 2, 3, 4. We're going to have 1, 2, 3 zeros. So each one of these squares represents 0.0001. How many of those do we have? 4. These 10 blocks represent our next digit over. There are how many? I count 5. The 100 blocks are our next digit over. There's how many? There's 2. Now we need 3 zeros, and we've only got 2 digits in front of that 4. So now we need another one of those. This should be 0.0254. How does changing the value of the small square change the value of the expression? Well, changing the value of each small square is really just changing this. Where do the digits go? Each time we change the value of that small square, We're just moving the decimal point over. Select at least two different powers of 10 for the small square. Well, the easiest one to do with that would be 10 to the power of 1. If each one of these small squares is 10, that's 40. So each one of these is 10 of those. It would be 100. There are how many of those? There's 500. And then these big ones would be 1000s. There's how many of them? There's 2. Put all those together, and that is 2,540. How does that differ from our original number? Just the location of the decimal point. It says select at least 2. I did 1. You're on your own to figure out another one. Now this next section says your teacher will give you a card that tells you whether you're partner A or partner B. The partner work doesn't really work out online. Unfortunately, there's no good way to give you a partner to have to work with, because that's troublesome when we're all working from home. So when you get to a problem like this, I'm going to suggest skip them. Try it if you know how to answer it. If you don't worry about it. Quick view of these. Around the world, about blank pencils are made each year. You could also Google that pretty easily. Mass of a proton is blank kilograms. Hey, Google. Turn off my phone that heard me say that. Speaking of them, are you ready for more questions? A Google is the name of a really big number. A 1 followed by 100 zeros. If you square it, how many zeros will the answer have? Well, a 1 with 100 zeros is okay, a Google, which is a 1 followed by 100 zeros, as we were kind of just talking about, that is 10 to the power of 100. If you square it, how many zeros will that have? Well, squaring a number means multiplying it by itself. If we square this, multiply it by itself, how many zeros will that have? Well, using our exponent rules we already know about, if we are multiplying like bases, we just add the exponents. If you square Google, how many zeros will the answer have? 200. Now, if you raise a Google to a Google power, how many zeros will the answer have? So now, this number, which is a 1 with 100 zeros after it, Now we have to multiply the exponents. What's that going to do for us? Okay, next question. Now we're on to something else I'm pretty worried about. Are you ready for more questions or something? Try them. If you get stuck on them, skip them. Those are challenge problems anyway. If we have this, it says write this as a multiple of a power of 10. The easiest way to do these is always to think of one digit in front of where our decimal point is. Where would our decimal point have to move? That looks like 7 spots. To put our decimal point where I put it, we're making it a teeny tiny number, so we're going to use a negative exponent. Now, this one we're making bigger. The decimal point was after that last 0. That's 8 spots, but we're making it bigger. So if we're working with a really big number, we have a positive exponent, really tiny number, negative exponent, and our convention is always going to be that we want to have one digit in front of the decimal point. And that's it for today.